Hi, and welcome to the fifth tutorial of the Monty Hall and the Python. Sorry, I can't remember the name. Monty Hall and the Python. So we're using Python to solve the Monty Hall problem. And last time, we finally were able to run 10,000 simulated Monty Hall problem events. And we saw that when we did not switch our answer, we were right 33% of the time, which is kind of what it should be what we predict. When you have three choices and you pick one, you're going to be right 1/3 of the time. But then we found when we switched our answer, we were right 66% of the time. And for some people, that might be puzzling. So I wanted to go and kind of pictorially show what's happening, and that hopefully, if you're a little confused still, that might illuminate things for you. So last time I showed this picture where we had chosen this first door, the red door, and Monty Hall revealed this middle door, and then we had a choice. We could choose the red door or the blue door. So statistically speaking, what's happening here, if we draw a little dashed line around these boxes, I think that helps illuminate why you end up with the 33% result for keeping your answer and the 66% result for switching your answer. So our original choice here is in the single box, and you can see that that's 1/3 of all of the doors, right? This door here is just one of three. So if you pick that door, your chances of being right are 33%. Now when Monty Hall reveals one of these other two doors, he can only reveal a wrong door. And so if you chose right the first time, he can reveal either one of these doors, and that's okay. But if you chose wrong, there's only one of these doors he can reveal. And so if you think of it in terms of these two choices between your first choice or your second choice being a right answer and the wrong answer, you're 33% right over here and you're 66 or 67% right over here in this region where there's the two doors. In this particular case with three options. So that's the reason that switching your answer statistically gives you a chance of being right 66% of the time, or 2/3 of the time. So now the question becomes, what if you really generalize this? What if we went to a Monty Hall problem that looked like this, where now you've got 100 doors, and you just pick one door over here. And so we're going to change our code now so that we can do the Monty Hall problem, but instead of having just 3 choices, we can have 100 choices. And instead of revealing just one door, we could reveal maybe 50 doors or 98 doors or something like that. Okay, so let's go back here. We're going to just pull this down to 100 to start. All right, so we need to change our choices. So instead of it being A, B, and C, we could do something a little simpler. I'm going to clear that, and we'll say choices equals I in range 100. And I suppose we need to say I for I in range 100. So now our choices, instead of being A, B, and C, are just going to be numbers. So it'll be numbers 0 through 99. That'll be our choices. I may in a future tutorial show you, if you want to stick with the alphabet, there's a way to do that so that you could have an unlimited number of choices and still be able to use alphabet characters. So it's kind of interesting. So I'll show that later. But this is a much easier way to just get 100 choices easily. Okay, there's our choices. Now now we'll say how many reveals. So this is going to be how many doors does Monty Hall open, right? In a fair game, he might just open up one door and then you're left picking the other ones. But we can make this as general as we want. We'll start with just one door, and that should be fine. And we just need to go and propagate this variable in wherever we want. So we'll run through our code just to make sure everything still makes sense. So the correct choice will be a sample from the choices. That's still correct. The wrong choices will still be all the choices that are not the correct choice. My choice will still be a random from the choices. And if my choice is not in the choices, then I messed up. So that's good. So the reveals now will be, so they're saying sample, or you can make a list of all the wrong choices as long as my choice is not in that list. Okay? And then we'll take a sample from the reveal, but instead of just taking one sample, we will take how many reveals. Okay? So, and now instead of it being, instead of just taking the first one from that list, we need to make another change. So where do we find reveal? It shows itself up here, and we can say, instead of it saying C is equal to reveal, we could say, or C in reveals. Okay? So reveal is gonna, I see, reveal is going to be, still going to be a list. So, sorry, we'll leave that as reveal. Sample from the total list of how many, okay? And now we're saying the remaining choices are the C for C in choices, if not your original choice and not in what Monty Hall reveals. Okay. So in this case, why don't we say, why don't we show a print statement? We'll say print Monty Hall revealed reveal. We'll make this an F string, and reveal without an S should be a sample of all the reveals. So to make this interesting, we'll change this to 10, or I said 19, 10 reveals. Okay. And so we should see a printout of a list of 10 numbers as the revealed numbers. Okay, so we'll leave it so that we're still always switching. And okay, we print out reveal and the remaining choices of new answer. So then, so here, instead of just picking the remaining choice from remaining choices, we need to sample from the remaining choices. Sample from the remaining choices 1, and then adding the bracket 0 means we're just making it not a list but the actual answer. So our new answer is now still an answer. Okay. And so yeah, we can run this, well, we'll run it 100 times just make sure that it doesn't work. In fact, let me save this as my tutorial 3, even though I already saved it as the other thing. Okay. Alright, so we revealed 10 doors, and it shows that Monty Hall revealed, and it has a list of 10 numbers. I was right 0 out of 100 times. Well, that's not encouraging. Now, is it just because of low statistics? I don't know. What if we did it 10,000 times? So now it's going very long. How many times do we expect to be right? When there's 100 doors, you choose one. How often do you expect to be right? 1% of the time. Okay? Now if you change your answer and Monty Hall revealed 10 doors, now you're picking 1 out of 90, or less than 89, I guess. And so you would expect to be right even a little bit more often than 1%. So this says we were right 120 times out of 10,000, or 1.2% of the time, which is a little bit more than 1%. Now here's a interesting one. So if we pick one choice and then Monty Hall opened 98 doors. That's the maximum number that he could open. All that's going to be left is one answer. So we would expect, if we think of this problem rightly, that 1% of the time we'll be right on our first guess, but 99% of the time we'll be right by changing our answer if there's 100 doors and Monty Hall opens up 98 of them after our first choice. Okay? So let's save this. We've got 100 choices. He's going to reveal 98. We'll do it 10,000 times, and we'll cut out this print statement since we know it works. Okay. So it's running, and then, as I predicted, we were right 9,905 times out of 10,000 times. So we were right 99.05% of the time. So again, graphically, if you want to see that, right, we had this picture. Here's 100 doors, and you picked this one. You picked door number 0, door number 1. Then Monty Hall says, okay, I'm going to reveal 98 doors that have crap behind it, and there's one door left. Are you going to change your answer? I think you are, right? Because if you see these little tiny dashed lines here for the boxes, this answer, your first answer, had a 1% chance of being right. All these other doors have a 99% chance that's behind one of these doors, and he revealed 98 of them that it wasn't. So there's a 99% chance that that is the correct answer. And that's in fact what we see when we generalize this Monty Hall problem and show it with 100 doors. So thank you for watching. If there's a few more customizations that we could do, I may show them in the next tutorial after this, if there is in fact a tutorial after this. And otherwise, I hope you enjoyed this series, and thank you for watching.